In the previous sections of this course, we've looked at the forces that apply to a dancer's body and how we can use them to describe the way a dancer is going to move around in space. So the next progression in this course is then to describe or try to measure or describe how a dancer actually moves around in space. So to describe the actual movement that occurs, not so much the forces that produce the movement, but the actual movement that occurs. And in order to do that, we need to describe these concepts in this video of position that we have here and displacement. And then in the upcoming videos, we will look at what's called the derivatives of displacement. So the derivative of displacement is velocity. And the derivative of velocity is acceleration. And these are all concepts that describe movement. So let's start off with our ballerina here and look at her performing her leap. And for today's purposes, let's say she's done a really good job of this leap and she's jumped all the way from the edge of the picture here. So this is her start point. And here we have what we'll call today as position 1. So position 1 meaning P1 meaning position 1, the point where she started from. And now she's jumped all the way through the air here. She's gone through this big leap, and let's just say she's landed right on the stage at that point there. So she's finished her leap on the point there. So we'll call that position 2 or P2. P2. So there we have two positions, and displacement is as simple as saying, well, what is the difference here between position 1 and position 2? And for today's sake, let's say it is arbitrarily, it's 3 meters. So we can say that our ballerina between point 1 and point 2 has displaced herself. She has moved her position, she's displaced her body from P1 to P2, and that just happens to be 3 meters. It happens to be a measure of 3 meters in length. The term that's often used interchangeably with displacement, but is slightly different in biomechanics, is that of distance. So you could probably look at that space between P1 and P2 and say the distance that she's traveled is 3 meters. And you would be correct, because in the difference between distance and displacement is that displacement here has direction. So in order to truly describe the displacement that the ballerina has performed here in her leap, we would have to say that she has displaced her body's 3 meters to the right. So now we have a direction. Okay, a distance doesn't have direction, and so we could actually say that this arc here, the arc that the ballerina has moved through, the arc here that you can see here, up and through, that's actually the distance that our ballerina has moved through. But the displacement, because we're just going from point 1 to point 2, is 3 meters to the right. But the distance, in fact, the distance could equal something like 4 meters or 4 to 5 meters, because she's gone through this arc shape here. We've got this arc occurring. So because with distance we don't need a direction, we can describe these arced or these movements that aren't necessarily in a straight line, and we call those non-linear movements. But displacement typically is linear, so it's a straight line and it needs a direction associated with it. And when we have a displacement, which means a distance and a direction, then we can go on to the derivative of displacement, which is velocity, that we'll look at in the next video.